purpose of this video is to talk about footprints of components. As you can see in this picture, a resistor has this shape. It has leads on the two opposite ends. It's an axial component. The leads are on the same axis, and we usually bend the leads at 90 degrees, and the leads will go through holes from the top of the circuit board down onto the bottom. On the bottom of the circuit board we need to have annular rings made out of copper on which the components will be soldered. Over here on the right you see these two annular rings. The rings in red represent copper on the bottom side of the board, so we have one annular ring here on the left for the left lead, and we have another annular ring on the right for the right lead of the resistor. So those two will be on the bottom side of the circuit board, and on the top side of the circuit board what we see here in yellow is the silk screen, which is printed in ink, and the purpose of that is to assist us in inserting the component from the top layer down into the holes so that we can place the component in the right orientation. The second part that you see here is a transistor. This is how the transistor looks like, the physical appearance of a transistor. This specific one here with the transistor outline number 92 has a flat side on one side, and then on the other side is semi-curved, and it has it's made out of plastic, and it has these three leads coming out from one side. The leads are numbered, and each one of them has a specific purpose, so they cannot be swapped. They have to be connected in the right orientation on the circuit board. So here, when you insert this transistor into a circuit board, you need to have an annular ring that lead number 1 will connect into it, another annular ring for lead number 2, and another one for lead number 3. Here on the right you see the footprint of this transistor, the TO92 footprint. So if you see, as you see, here's the flat side of the transistor, which corresponds to this flat side here of the silk screen. Then this annular ring here on the left corresponds to is the hole where pin number 1 will connect to. Pin number 2 will connect in the middle annular ring, and pin number 3 will connect to the third annular ring. So again, this is the silk screen in yellow. It's on the top side of the circuit board, which will assist us in figuring out the correct orientation of the transistor. So here it is important to have the flat side facing down, facing this direction, and not place the transistor the other way. It could fit the other way if you place it, but it will not function because you will have the emitter and the collector, pins 1 and 3, will be switched, and the transistor will not operate. Actually, it could be also damaged. Here is another footprint of another component. This is a connector. This is typically a connector which you connect power to a circuit board, or sometimes input or output signals. This specific one consists of two pins. This is the top side of the connector, which will be sticking up from the top of the circuit board, and this is the bottom side, which will go through the circuit board and will be soldered on the bottom side or the foil side of the circuit board. Over here on the right we have the footprint of the connector, and as you can see there is one hole over here on the left corresponding to the place where this pin is going to connect, and here is the other hole on the right which corresponds to this pin on the right. Whenever you see a component which has multiple holes or annular rings, and one of them is square, the pad is square, that indicates pin number 1. So this is pin number 1, and it has to be matched to pin number 1 of the connector. Also, if you look at the silk screen here, Notice that the outline is square, which represents this square plastic piece holding the two pins. But notice also here this thicker yellow piece that represents this part of the plastic bag, and that's the key which allows the female part of the plug, which will come from the top, to connect to the connector to be inserted the right way. And actually most of these are keyed so that it can go only one way, so you cannot connect it the other way and damage the circuit. The next component is an LED, or a light emitting diode. A light emitting diode has a positive and a negative, so it has to be connected in the correct way. The negative, or the cathode, is usually the shorter lead, and up here on the edge of the periphery of the housing of the LED, there is a slight flat surface. In other words, the ring is nice and smooth all around, except on the side which is opposite to the cathode, it has been flattened a little bit. So that's an indication, or a visual, and a tactile. You can actually feel it with your finger, that it is flat, indicating that this is your cathode, or the negative. The longer one is the anode. Over here we have the silk screen and the annular rings. This is the bottom side. This is the side where is the cathode, so the flat side, or the square pad is your cathode. So this lead has to connect here. This is the anode, and the other lead therefore has to connect there. So here is the footprint of the LED. So the next one is the circuit that we're going to put together, practice circuit 1. It consists of one connector, 2-pin connector, 2 resistors, 1 transistor, and 1 diode. The way these are going to be connected is determined by the schematic. So the schematic is our guide that will tell us how to connect the components. And as you can see from here, we'll go from the negative of the connector, and we'll go down into the emitter of the transistor. So we have to make a connection, possibly from one of these two leads here down to the negative of the connector. Also, from the base of the transistor, we're going to go to R1. That's this lead right here, and from the other side of R1, we're going to the positive of the connector. So this is our guide. The schematic will help us do the layout and the connection of the circuit using Express PCB.